Hi everyone, this is a last minute Lucy review for a right triangle quiz that we're going to be taking. So let's get started. What to review? I would expect that you would be reviewing Pythagorean Theorem, area of a triangle, acute, obtuse, and right triangles, how to distinguish what they are. Geometric means, meaning you're going to be using proportions to solve a side, and 30, 60, 90 right triangles, and 45, 45, 90 right triangles. So in these first two examples, we're just going to try to find the missing side. And so in order to find the missing side, let's just call that, I don't know, x. We're going to use Pythagorean Theorem because this is a right triangle. And so this is our leg squared plus our leg squared is equal to the hypotenuse squared. And remember, the hypotenuse, or the largest side, or the longest side, is always opposite the largest angle. So the longest side is always opposite the right angle, or the largest angle. So we're going to say leg squared, so 5 squared plus 11 squared is equal to x squared. So we have 25 plus 121 is equal to x squared. So we're going to add 121 plus 25. I'm going to get 6, I get 4, I get 146. And so 146, square root of 146. So what we're going to do with that is we have x squared is equal to 146. And what we're going to do is we're going to take the square root of both sides, and we're going to say x is equal to the square root of 146. Now, I don't want you to use a calculator to actually, I don't want you to use a calculator to give me a decimal point, but you can use a decimal or a calculator to find, to reduce it if you have to. So meaning if I were to divide 146 by 2, this would be the square root of 2 times the square root of 73, which I don't actually see something that would go into that 146. So basically 146 looks like it's, that's the lowest that I could reduce it. And so therefore my answer would just be the square root of 146. We're solving, you could put that in solution sets, and we're done. For this one, we're going to try to find this side, which is not the longest side, which is not the side that I'm going to set everything equal to because it's just a leg. So leg squared, so we have x squared plus 7 squared is equal to the longest side, which is opposite the largest angle, so equals 9 squared. So we have x squared. We're trying to solve for x squared. So we get x squared plus, let's say, 49 is equal to 9 times 9, which is 81. And there we're going to subtract 49 from both sides. I get x squared equals 81 minus 49. And what that's going to give me is, let's see, 2 and 3. So we have 32. So x squared is equal to 32. I'm going to square root both sides, and when I do that, I get x equals, and I know that the square root of 32 can break down into perfect squares, meaning that that could be 16 times 2. Well, the square root of 16 is 4, so x would equal 4 root 2. So that side right here is going to be 4 root 2. The second example that we're going to cover is basically to find the area of an isosceles triangle. Now, in an isosceles triangle, what you do know is that if both of the sides have equal lengths, then also both these angles have equal lengths too. The angles opposite the congruent sides are congruent. Additionally, if these are congruent, both of them have the same measure, 12 and 12. But one very, very cool thing is that if this is an isosceles triangle, this height that comes straight down is going to break this base up into 2 equal parts, which would mean this would be 10, and this side also would be 10. Now remember, what we're trying to do ultimately is we're trying to find the area of the triangle, meaning the area of our triangle is 1/2 base times height. And the very important thing regarding area is that the base must be perpendicular to the height, right? They have to make a right triangle, right? 4 right triangles. So therefore, my base would be this whole length right here. And this height is this value here. This height is my, that green line right there. So then my base, I'm going to go 1/2 my base, which is 20. But I don't have my height yet. So in order to find my height, it looks like I'm going to have to use Pythagorean Theorem, which would be, I have 2 sides. So I'm going to use Pythagorean Theorem if I have 2 sides, and I'm trying to find the third side, and if I have a right angle within that triangle, which I do. So we're going to say this leg squared plus this leg squared is equal to the hypotenuse squared. So we're going to say 10 squared plus h squared is equal to 12 squared. So we have 100 plus h squared is equal to 144. We are going to subtract 100. We get h squared equals 44. And then I'm going to square root both sides, and I'm going to get the height is equal to the square root of 44. Now, that being said, I do know that the square root of 44 will break down because 4 will divide into 44. So this will break down into baby little roots, right? Root 4 times root 11. And that equals the height. Well, the height then is going to equal square root of 4, which is 2 square root 11. So that's my height. Now, what I'm going to do with that is I'm going to plug it in right here. Because remember, ultimately, I'm trying to find the area of my triangle. And the area of my triangle is going to be 1/2 base times height. And so remember, we already have the base. The base is 20. But we didn't have the height. So now the height, we know, which is 2 root 11. And so all I have to do is multiply these out. Remember that when you multiply these out, right, this 2 will divide into one of these values, either this 2 or this 20. I'm going to cancel out this 2 divided by 2, and I'm going to get 1. And now I just have the area of this triangle is going to be equal to 20. Sorry about that. It's going to equal 20 root 11, and then this is units squared. So just remember, area is always units squared because it's your base times your height, okay? For these types of problems here, your job is to discover whether these triangles here could be acute triangles, right triangles, or obtuse triangles. And the rule is that if we already know a squared plus b squared, those are our 2 legs. If the squares of the 2 legs, right, you've got the 2 squares and you're adding them. So the sums of the squares is equal to c squared, which is the largest side, squared. Then that becomes a right triangle, okay? However, if you have these 2, a squared plus b squared, that's greater than c squared, and that is actually going to be acute. And I know it sounds odd, right? Because we're reading it, a squared plus b squared is greater than, and you think, oh, that's obtuse. But actually, they want you to read it this way, c squared. And so they're basically saying c squared is less than the sum, then it's acute. And then, of course, lastly, if the sum of the 2 sides of squares, the sum of the squares of the 2 sides is less than c squared, or if I read it from right to left, c squared is greater than the sum of the 2 sides, then that is obtuse. All right, so that's what we do need to remember. Like in our head, we have to remember that. So I'm going to add the 2 sides. I'm going to add the squares of the 2 sides. So for the first triangle right here, this one, we're going to say 3 squared plus 3 squared, and then I'm going to have, I don't know, and then here's 5 squared. And so 3 squared is 9, so 9 plus 9, which is 18. And 5 squared is 25. So we have 18 is less than, or I can say 25 is greater than, and 18. And so this would be actually what we call an obtuse triangle. For the second one, again, I'm going to say 3 squared plus 4 squared. I'm adding the sums of the squares of the 2 smaller sides. And then not sure for the third side, so there's 5 squared. So we have 9 plus 16, which is 25. And 5 squared is 5 times 5, also 25. So if these are equal, right, that we have this one right here, if they're equal, then this is going to be a right triangle, meaning this little corner here is right. Another option too, just to remember, is that this is a triplet. See the 3, 4, 5? So remember your Pythagorean triplets. There's 3, 4, 5. 3, 4, 5. There's 5, 12, 13. There's 7, 24, 25. And there's 8, 15, 6, 7, 16, 17. What was that? Let's figure that one out in just a minute. But anyway, it's not a thing, like it used to be a thing where you go 4 plus 5, and that's 9. Square root of 9 is 3. 12 plus 13 is 25. Square root of 25 is 5. 24 plus 25 is 49. The square root of 49 is 7. But the 8, 15, 17, that's it. 15 plus 17 is not 64 or any, you can't square root that. So this one is just the non-one that doesn't work every time, so it's not a thing. Lastly, we have the last triangle. So we have 3 squared, this 3 squared, plus 5 squared is not sure to 6 squared. So we have 3 times 3, which is 9, plus 25, and 6 squared is 36. So we have 25 plus 9 is 34. And 34 is less than 36. Again, this one is less than. So therefore, this must be also obtuse. Okay, so, all right, next. For this problem here, your job is to solve for A. A is right there. And so in order to find A, which it looks like I'm going to use the Pythagorean Theorem and go 3 squared plus my height squared is equal to A squared. Except I don't have my height and I don't have A, which is the segment that I'm trying to find. So before I can do that, it looks like I need to find X, which is that height. And it does also look like they gave me that this length is 3 and this whole length is 10, which would make this 10 minus 3, which is 7. And remember our geometric mean, which says 3 is to X as X is to 7. So you're going to say 3 is to X as X is to 7. We're going to cross multiply here. We're going to multiply across, right? X times X is X squared. 3 times 7 is 21. So X is going to equal the square root of 21. And so this value right here is going to be the square root of 21. So right here, I'm going to change that now to the square root of 21. So in order to find A now, which is this length, I want to use the Pythagorean Theorem. So I'm going to say length squared, which is 3 squared, plus the square root of 21, and then that squared is equal to my hypotenuse, A, which is squared. So we're going to say 9 plus 21 is equal to A squared. So A is equal to the square root of 21 plus 9, which is 30. And is there a number that goes into 30 that is a perfect square? So 4, no. 9, no. So this would be my solution for A. For these two problems here, this right here is a 30, 60, 90 right triangle. For this one, your job is to find the missing sides and lengths, but I guess I didn't put any sides and lengths here, so let's add a side or a length. So we're going to start with, let's say 3 to opposite 30. That would mean opposite the 90 is twice that. So that would be 2 times 3, which is 6. And then opposite the 60-degree angle is going to be A, which is this 3 root 3. So it would be 3 root 3, okay? Let's do another one. Let me erase that, and let's do another one, okay? And so for this one, let's say opposite the 90 degrees, which is 2A, let's say that's 10. So if this is equal to twice what's opposite the 30, let's say opposite the 30 is A. So that would mean A is equal to 5. So this would equal 5. And then that would mean opposite the 60 would be 5 root 3. Okay? Well, let's erase that. And I know you guys can rewind in case you need to see that again. Just watch it again. So let's say now opposite the 60 is, let's say, 5 root 3. Well, opposite the 60 is 5 root 3. So that would mean 5 root 3 is equal to a root 3, right? And so therefore, a is equal to 5 root 3 divided by root 3, which is just 5. So opposite the 30 is 5. And then opposite the 90 is 5 times 2, because this is 2a, and that would be 10. All right, so let's just make it one more step. Let's take it one more step and make it a little bit more difficult. What if opposite the 60 degrees was, let's say, 12? Well, opposite the 60, remember, is a root 3. So instead of it being 5 root 3, right, I'm going to make that 12. And I'm going to divide by root 3. And then when I do that, I get a is equal to 12 divided by the square root of 3, which, of course, we're not going to leave a root on the denominator. We're going to multiply by root 3 over root 3. And we're going to get 12 root 3 over 3. Except 12 divided by 3, we can cancel out numbers with numbers. So 12 divided by 3 is 4. So that would mean a is equal to 4 root 3. So opposite the 30, which is my a value, is 4 root 3. And then remember, opposite the 90 is twice a. And so that's going to be 2 times what's opposite the 30. And so that would be 8 root 3. Okay? So just a reminder for those who forgot, where is everything. Basically, opposite, let me just redraw this triangle real quick. Opposite the 30 is your a value. Opposite the 60 is a root 3 value. And opposite the 90 is twice a. So whatever is opposite the 30 is twice a here. So sometimes if you know that this is 20 and this is 10, you automatically know that this is a right triangle because that's half of that. So that means that's 90. That must be opposite my 30, right? And therefore that would be 10 root 3. For this triangle on the right, this is a 45, 45, 90. And I know that because of the slashes here, which tell me that it's an isosceles triangle. It tells me that the side opposite, if the sides are congruent, the angles opposite those congruent sides are also congruent. And because these two, the sum of this angle plus the sum of that angle, has to add up to be 90 degrees, because that's 90 already, that would mean that they have to be the same value, or so the same measurement. So therefore, they're both equal in measurement, so they're both 45 degrees. Now, remember, whatever this side is, and I'm going to use x instead of a, because I like to use a's with the 30, 60, 90, but across from the 45s, you have x, and then this becomes x root 2, okay? So if this was 5, this is 5, and that would make this side 5 root 2. Or this is 4, and this is 4, that would make this side 4 root 2. What's unique about these ones is that if you ever forget that little rule, x root 2, right? And I'll put that down here so we can remember that. So x, and then x root 2. If you ever forget that, what's unique about the isosceles right triangle is if you have just one side, right? You can say, well, I don't know what the other side is, right? But it has to be 5. And therefore, if we don't know what this side is, we know it's 5 root 2, but let's say we completely forgot for a moment, you can say 5 squared plus 5 squared is equal to that opposite side squared. I don't know, x squared. So we'd say 25 plus 25, which is 50, and 50 equals x squared. We would take the square root of both sides, and we would get x equals the square root of 50. Now the square root of 50, again, breaks down to root 25 times root 2. Square root of 25 is 5, so now that's 5 root 2. 5, 5, and then 5 root 2. So you always can find a right triangle. You can do that this way. It's always going to be like that because the isosceles triangles are unique that way. Isosceles right triangles. The other thing, though, is I know we did the 5, 5, 5 root 2, 10, 10, 10 root 2. What if this was 7 root 2? Going backwards, of course, this would be 7, and this would be 7. But what if it wasn't something quite so nice and easy like that? What if it was something like 10? That's 10. How do I find the length of the side? Well, of course, like I just said, I can say x squared plus x squared is equal to 10 squared. Leg squared plus leg squared equals 10 squared. That would give me 2x squareds equal 100. X squared equals 50 if I divide by 2. So x equals the square root of 50, which we just said was 5 root 2, right? So this would be 5 root 2. And somebody might go, well, how does that work? You know, you said if this was 5, this was 5, that was 5 root 2. But what I'm saying is, what if that was 10? And the trick is that going backwards, you can divide by 2 and multiply by root 2. Because realistically, you're setting this equal to x root 2, which means you're dividing by root 2. Additionally, if you wanted to check your answer, you would say 5 root 2. This, of course, would be 5 root 2. This would be 5 root 2 root 2. And root 2 times root 2 is root 4, which is 2. 2 times 5 is 10. And so you can check your work with that. So I have one last challenge. So this is, I want you to find all the sides. And you already know all the angles because these are 30, 60, 90. 60, that's 90, that must be 30. If that's 45, that's 90. This is also 45, which means those lengths are going to be the same. What we know is this is 4. So opposite the 30 is 4, which means opposite the 90 is twice that, which makes that side 8. What did I want 4? I don't think I want it. Actually, I'm going to switch that out really quick because I didn't want 4 for the first time. So let me erase this. And I'm going to make that 3 first, and then we'll go to the 4. So if this was 3, opposite the 30 degrees is 30. So then opposite the 90 is twice that. So 3 times 2 is 6. And then opposite the 60 degrees, remember, is my a root 3. So that means if this is 3, and that's my a value, right, then opposite the 60 is going to be 3 root 3. So we have that side. Okay, so opposite the 60, remember, is our a root 3 for this problem up on the top. So we have 6 is equal to a root 3. Now the trick is to actually divide by 3 and multiply by root 3 going backwards. But to show you that that's how it works, we're going to divide by root 3 on both sides. This cancels. I get a is equal to 6 divided by root 3, which we're not going to leave a root on the denominator. And we're going to multiply by whatever is now on the bottom, on the denominator. And I'm going to get 6 root 3 over 3. Well, 3, and this is where I was saying, to divide by 3 and multiply by root 3. Because see, here I'm dividing by 3 and multiplying by root 3, right? So then 3 cancels into 6 twice, and I'm left with 2 root 3. So across from the 30 degrees, that one, across from the 30, which is this little side right here, is going to be 2 root 3. So this is 2 root 3, which if that's 2 root 3, that makes this 2 root 3, because those are the same lengths, because it's a 45, 45, 90. And then that would make this 2 root 3 root 2. Which would then be, of course, 2 root 6 for this length of the hypotenuse. The only thing we don't have is this length right here. And so remember, across from the 30, we have 2 root 3. Across from the 90 is double that. So that's going to be 2 root 3 times 2. And so this length right here, this long length here, is now 4 root 3, because that's 2 times 2, which is 4. All right, cool. I did say that we could do one more with the 4, so if you want to stick around and do that one more time, we're going to do that. So I'm going to erase all of this. And in doing this, okay, If this was a 4 instead, then opposite the 30 is a 4. Opposite the 90 is going to be double that, so that makes that 8. Opposite the 60 would be 4 root 3. So the first triangle is pretty simple. The tricky part is right here, because remember, across from the 60 is your a root 3. So we have 8 is equal to a root 3. So that means a is equal to 8 divided by 3 and multiplied by root 3. Okay, which is fine. It's just this value right here. So that value is 8 root 3 divided by 3. Also, 8 root 3 divided by 3. This value here is double that, so times 2 would be 16 root 3 divided by 3. And this is completely fine to leave it in this form. It's completely fine. I don't want a decimal. I just want you to leave everything in root form. And lastly, across from the 90 is going to be twice what's across from the 30. So across from the 30 is my 8 root 3 over 3. So 2 times 8 root 3 over 3 makes 16 root 3 over 3. Holy cow, look at that. So anyway, so that's kind of cool. That's all I have for you. So that's a good review. I wish you the best of luck on your quiz tomorrow. And come in for help in the morning. I get there very early. And if you have any questions about this video or anything from your homework, please stop by. All right. Thanks for watching.